This is the second video under Financial Management Unit 1, Introduction to Finance. And in this section, we're going to cover the topics about time value of money, simple interest versus compound interest, and the concepts of present value and future value. The idea behind this is that these would again be some of the instrumental parts in terms of our understanding on how do we value securities, and the concepts that we learn here in terms of time value of money and present value and future value are going to have far-reaching implications and applications in financial services as such. Right, so let's begin with the first concept here, which is time value of money, and let's try and understand what does this stand for. The question is money today or later, right? Now imagine someone gives us two options. Take rupees 100 today or take rupees 100 after a month. If you think about it for a minute, almost all of us will take option one. We would want to kind of take the money today because of the uncertainty over a month. So there are multiple things. There is uncertainty over what will happen over a month. And the fact that you get the money early, you can do something with the money, right? So there is an opportunity lost if you take it after a month, right? If you have the money in your hand, you can probably use it somewhere. If you don't have the money, what will you do with it any which ways, right? So all of us will take option one. Now imagine that someone is asking you to pay for a certificate holding which will entitle you to get this 100 in a month, right? So instead of the money, people are saying there's a certificate. You can get the certificate today, and if you hold it, then after 1 month, you can get 100, right? Now, how much would you be willing to pay for this? Once again, if you think about it, if we have established correctly that taking rupees 100 today is better than, is going to give us more satisfaction than taking rupees 100 after a month, then logically this stance should be more valuable and this should be less valuable for us, right? Now, if taking rupees 100 after a month is less valuable, then today, and logically rupees 100 today is equal to rupees 100, rupees 100 after a month today may be equal to rupees X. We have clearly said that rupees 100 today is more valuable than this. So A is more valuable than B, right? If A is more valuable than B, then the certificate that gives us B has to be less than 100. So the value that you will pay for this certificate is going to be less than 100. The price of the certificate will be less than 100, or 100 will be greater than the price. That seems logical, right? You would pay lesser for a certificate that gives you 100 after a month than, let's say, something that gives you 100 today. If you have two certificates, one that gives you 100 today, for that you'll pay 100. But if something gives you 100 after a month, you're essentially taking on an uncertainty and you're losing an opportunity because you will get the money after 1 month, and hence the value of rupees 100 after a month should be lower than the value of rupees 100 today. Basic logical principles, right? Now, but exactly how much would you be willing to pay for it, right? How do we find out what is going to be the value of that certificate, that if you buy this certificate and you hold this, you are entitled to rupees 100 after a month, right? Now think about it this way. If you were to get this amount today, you could earn some interest on it. However, if you get this after a month, you will lose that interest, right? So you should be willing to pay only that much, which is the interest that will generate 100 at the end of the month. Effectively, you are kind of foregoing that interest, right? In other words, let's assume you are borrowing this money from someone and you don't want to make money yourself. If you borrow some amount X today, then after a month you have to pay X plus interest, right? and you know that you're going to get 100, and if you don't want to make a profit, x plus interest should be 100. So x should be equal to 100 minus whatever interest you are going to pay for borrowing 100, for borrowing the amount that you're paying today, right? So if the monthly interest is rupees 2 that you're going to get per rupees 100, then you'll be willing to pay about 98, right? You borrow 98, you pay an interest of 2 out of the 100 that you get, right? So effectively, the first thing that we established was position B, which is take 100 after a month, is going to be less than A. So A is going to be greater than B. That's the first thing that is established. The second thing is what is going to be the value of B, right? That's the important parameter that we have to decide on. The value of B is going to be effectively the interest that you have to pay in order to kind of raise that money, right? So if you borrow an amount X and you have to pay an interest Y, X plus Y is going to be 100, right? And that's basically the second tenet that comes out, is essentially you will be willing to pay lesser and to an extent of effectively the interest you are foregoing for not taking this rupees 100 today. Logical again? So let's move ahead. Now note that in both the cases, the amount is the same, right? So there is this concept of value versus amount, or price versus amount, that comes in, right? The amount is the same. You're going to get 100 at time 0 and you're going to get 100 at time 1. There's no difference between the price or the amount you're getting, but the value is different. The value is not the same. The 100 today will be valued at exactly 100, but 100 after a month will be valued approximately at 98, right? And that is why it is important for us to actually understand this concept of time value. There could be projects, one of which gives a cash of 1000 in year 1, another one which gives a cash of 1000 in year 2. You will almost always end up with the cash flow in year 1. Earlier the better, the faster you get money, the better it is. And one of the reasons why money loses its value over a period of time, right? It's losing its value if you're taking it after a month, is inflation. It is the uncertainty that the prices will rise in future. So what rupees 100 can buy today, you will not be able to buy the same amount with rupees 100 after a month or after a year, right? So all of us will ask for a slightly higher amount if you're getting the money after a while. Now think of it, businesses, when they sell to a client, they typically say that if you pay in 30 days, you pay us 100. If you pay beyond 30 days, you have to pay us 101 or 102. That extra 1 or 2 is the compensation for the opportunity lost or the risk or uncertainty that you're taking on account of inflation. You're saying that if you pay early, you pay the same amount, but if you pay late, then you have to pay more because the value for me is going to diminish in future, right? So you can't pay me the same price after a month or a year because I can't buy the same amount of goods with that money. I need to buy I need to be able to buy the same value worth of goods, and for that you'll have to pay me more, right? So effectively the value is what we are talking at, right? So 100 today is valued at 100. 100 after a month is valued at 98. It's quite possible you would want 102 here. So in other words, 100 today would be equivalent to 102 after a month if you're assuming 2 rupees per 100 interest a month, right? So if someone says I can give you 100 today versus someone saying I can give you 102 after a month, these two now become indifferent. You can accept either because the guy who's paying you is compensating you for holding it for that 1 month, right? That's the concept of time value of money. Earlier the better. The farther you go in future, the bigger the amount you will ask for to get compensated for the same risk, right? Is because you are delaying your gratification that you can get with the amount that you're going to receive, right? You're delaying the consumption of that amount. You're foregoing an opportunity. You are taking an uncertainty that prices could rise in future, right? So that's the concept of time value of money. Earlier the better, later you would want a higher amount for you, right? Now next we move on to this concept of simple interest with versus compound interest. We would have studied this in basic maths earlier. Simple interest is if you deposit money with someone and you earn interest only on the deposited money. That's called as simple interest. Let's say you give me 100 rupees and I promise you a 10% interest. In year 1, I give you 10. In year 2, I'll give you 10. In year 3, I'll give you 10. In year 4, I'll give you 10. Note that every year I'm going to give you 10% on the initial deposited money. It will generate the same amount of interest every year, right? Now that's in a sense how if you don't add interest on the component of money invested, that's how it works. Now in the case of compound interest, however, you earn some interest on our deposits, and this interest is also possible to get deposited to earn more interest. So if you invest 100 at 10% compound interest, in year 1 you get 10, but in year 2 the interest now gets calculated on 100 plus 10, which is 110. 10% of 100 plus 10 is going to be 11. So the second year you get 11. The third year your 10% is going to account on this entire 3, which is 121. So you're going to make 12.1. The fourth year your interest is going to get compounded on these 4. So that will be about 13.3 or something. Under compound interest, you will keep generating increasing amount of interest every year because you are getting interest on the interest earned. That's the important premise that you need to learn. If you're not taking money out of your bank account, whatever comes as interest in the first year is on what you will make the interest in the second year as well. This is called as compound interest. In a sense, life would work largely on compound interest. If you put 100 rupees in a bank, they'll give you 10 the first year, and then the next year on the entire 110 they will give you the money. On the contrary, simple interest is where the borrower, let's the bank, you put in 100 rupees in the bank is the borrower, right? They give you 10 the first year and they give it to you. So with the bank, only 100 is left. They've given out the 10. So next year they'll give you interest only on that 100. Again they give out the 10. So if they are paying out at the intervals when the interest is being calculated, then you will have simple interest. But if they keep the money with them, then you will earn interest on interest, which is compound interest, right? Now an example will understand and make this clearer. And this is a stark example. That's an extreme example that we're looking at. Compounding is a significant concept in the world of investment and finance, right? Can have far-reaching implications. I'm taking an extreme example to understand it. Let's say you invest 100 rupees on simple interest or compound interest. Every year you have 100% interest that gets generated. So under simple interest, you have 100. In year 1, you will get 100% interest. In year 2, you will get 100% interest. In year 3, you will get 100, and so on and so forth. At the end of 20 years, you will end up with rupees 2100, which includes the initial 100 rupees of the principal and 2000 rupees of the interest added over 20 years, right? In the case of compound interest, however, interest every year will double, right? So the first year on 100, you will make 100. But the next year, you have 200 on which you will make 200. The next year, you have 400 on which you will make 400. And the year after that, you have 800 on which you will make 800. So this is 1, this is 2, this is 3, this is 4, and that continues, right? Now, in the first case, we saw every year the interest was 100, so we know what value we will end at the end of the first year. Here, the values will keep doubling every year, right? This takes huge proportions as you go along. Look at the simple interest example. The yellow bar is the principal, the red one is the interest that is getting calculated. At the end, you end up with 2100 rupees, right? In the case of compound interest, however, every year the principal keeps adding up the interest amount as well. At the end of 20 years, you will end with about 11 crore rupees approximately, as against 2100 rupees here. And that is the power of compounding. If you keep compounding it at that pace, you will end up with a significantly huge amount because you keep getting interest on interest. And that is why compound interest is commonly known as or referred to as the eighth wonder of the world, is because you just don't realize how quickly it adds up and how quickly you start making money on the interest that you have generated. The longer you stay invested, the faster the returns get generated in compound interest, the bigger the returns that can get generated under compound interest, right? That's the concept of compound interest, right? So let's quickly summarize. We said present value of 100 rupees is high today. Present value does not have to take any uncertainty on the account of inflation, and hence the value of present value is higher. If you're getting a cash flow today, the value will be higher. Value of 100 is less in future is because there is an uncertainty. More money needs to be given in the future to compensate for the interest foregone. If I had given you the money today, you would have generated some interest on it. If I give you the money after a month, I need to compensate you for that interest that you have lost, right? That's the simple premise of present value and future value. Now let's put them in a form of a mathematical equation. Suppose you invest rupees 100 in a bank today at 10% interest rate. At the end of the next year, your bank account should have 110. How do you get it? 100%, 100 rupees into 1 plus 10%. Right? So effectively you made 100 plus 10% into 100. That's the interest. In this you can take 100 common, and as you take 100 common you get 1 plus 10% in your equation. That should give you 110. Correct? Logical? That's how you solve it. So the generic formula becomes future value, in our case 110, is equal to present value, which is 100, into 1 plus the interest rate, whatever is the expected interest rate or applicable interest rate in the market. Logical? Now let's assume we say we are investing this for 2 years. If you're investing it for 2 years, at the end of the first year you get 100 into 1 plus 10%. This is at the end of the first year. This is equal to 110, right? Now on 110 in the second year, you are again investing it at 10%, correct? Now this 110 can be replaced with this equation, right? So what you do is you write 100 into 1 plus 10%. That's the amount after 1 year. And this entire amount multiplied by 1 plus 10% is going to give you 121. You can simplify it to write 1 plus 10% whole square. If you invest it for 2 years, you put 2 there. So the value, future value, becomes present value, which is 100 into 1 plus the interest rate raised to the power 2. I can, instead of 2, if the number of years is n, I can put it as n. That's the generic formula. So future value is nothing but present value into 1 plus r to the power n. Correct? That's the concept that we have just finalized mathematically, right? Now turn the other way around. Suppose you want to have 110 in the bank account at the end of the first year, right? Same question. We said 100 invested at 10% is going to give me 110. Now I'm flipping it around, saying if I want 110 and I want a 10% return, how much should I invest today? Same equation, right? I should get 100. All I'm doing is I'm shifting 100 to one side and dividing 110 by 1 plus 10%, right? That's what I'm doing. And that is the concept of present value. You're saying 100 is being given by whatever is the future value divided by 1 plus the interest rate in our question. Correct? Do this for 2 years. If you're saying you're going to get 121 after 2 years, that's a mistake. This should be 121. Suppose you want to have 121 in the bank deposit. You have to invest X amount today. You're investing it at 10% for 2 years. That's going to give you 121. So what you're saying is that X is going to be equal to 121 by 1 plus 10% raised to the power 2. You solve for this, you'll get 100. Right? So the equation becomes present value is equals to future value by 1 plus the interest rate raised to the power 2. In this case, future value is 121. 1 plus 10% raised to the power 2 is going to give me 100. If you want to use generic data, 2 becomes n, the number of years. Right? So that's how you kind of go ahead and calculate the value, the present value as such from a future cash flow. Now, let's assume we're going to kind of value an asset. Right now, an asset can generate a certain amount of cash flows. That's what we said. So at time 0, there is a value. Time 1, there is a cash flow. Time 2, there is a cash flow 1, cash flow 2, cash flow 3, all the way up to n years. How do you value it? Right? Let's take an example and we'll understand. Suppose there are multiple cash flows. We have already established the equation for present value. Now let's say a project gives you 3 cash flows, year 1, year 2, year 3. How do you value it? Let's first divide this into, let's say, 3 assets or 3 projects. There is one project which gives you 100 after first year. There is the second project which gives you 110 after the second year. And there is the third project which gives you 115 after the third year. How do you value this? So the first one gets valued as 100 divided by whatever is the interest rate. Right? 100 divided by whatever is the interest rate. So I'll write it like this, 100 by 1 plus r, and I'll cancel this out. The second one gets it as 110 divided by 1 plus r square. That's the value that we just saw, the present value. The third one is going to become 115 by 1 plus r raised to the power 3. And if there was a fourth cash flow, you would have raised it to the power 4. This, remember, we have divided the same asset into 3 different assets, right? Now, if you were to kind of get all these 3 together, that would have been this, plus this, plus this, right? The first cash flow present value plus the second cash flow present value plus the third cash flow present value. If these were 3 different projects, but they're not 3 different projects, they're the same project, right? But that doesn't really make a difference to us, does it? So effectively, the value of the first cash flow present value is given by this. The value of the second cash flow present value is given by this. The value of the third cash flow present value is given by this. Just like if there were 3 different projects, the total value would have been the sum of these. If they are the same project, the total value will still be the sum of this. That is how you end up evaluating the value of an asset, which is going to give you a series of future cash flows. Right? We'll have a detailed discussion in terms of what is this rate to be used, but it suffices to say that if you want a return of R%, this is the present value you should be paying here. In our earlier example, if I was getting 110 at the end of the first year and I wanted a 12% return, then I should have done this in our earlier example, correct? I should have done this to get the value, which probably would have been close to 98. So if I buy this for 98, effectively 12% return gives me 110. That's how we try and find out the present value of an asset. This is what is called as the present value formula. This process is known as discounting. the cash flows. Right, this process is known as discounting the cash flows. You could also treat this slightly differently. Instead of saying you're going to divide it, what you can say is you're going to take 100 and multiply it with 1 by 1 plus r. You're going to take 110 and multiply it with 1 by 1 plus r square. And you're going to take the third one and multiply it with 1 by 1 plus r cube. Now this, and this, these three are called present value factors, or they are called discount factors. You can calculate these discount factors or present value factors and then multiply. It's the same mathematical calculation, just that you're taking the reciprocal 1 by 1 plus r and then multiplying, which is the same as dividing by 1 plus r. Correct? That is how you will find the value of an asset, the present value of an asset. That is where we will end this particular section. Our subsequent sections start talking about topics around compounding and the frequency of compounding and specific kind of cash flows, which could be termed as annuities or perpetuities.